If a plus bi is a 0 of p of x, and p of x has real coefficients, then a minus bi is also a 0. You might have noticed this with the last problem. So this breaks down to two zeros, right? 3 plus I over 2 and 3 minus I over 2, which are really 3 over 2 plus 1/2 I and 3 over 2 minus 1/2 I. So these guys are conjugates. The idea is if you know 3/2 plus 1/2 I is a 0, then automatically the conjugate 3/2 minus 1/2 I is a 0. If you have real coefficients. Okay, and that's conjugate pairs theorem. P of x is equal to x to the 4th minus 2x cubed minus x squared plus 6x minus 6. Given 1 minus I is a 0 of P of x. So you're told 1 minus I is a 0. Find the rest of the zeros. Okay. Does this polynomial have real coefficients? Yeah, so conjugate pairs theorem applies. If 1 minus I is a 0, what's the conjugate of 1 minus I? 1 plus I is also a 0. But you start with 1 minus I. So you're actually gonna divide. Syntactic division works great with complex numbers. And you're actually going to verify, just like we did in the previous problem, you're gonna verify 1 minus I is in fact a 0. Up in the corner, we're gonna put 1 minus I, and we're gonna do the syntactic division. So essentially we're dividing by the quantity x minus the 0 of 1 minus I. So 1 minus I goes up in the corner, and then the coefficients, the usual 1, -2, -1, 6, and -6. Okay. So now we have to think about the process of synthetic division, which is why I've shown you so many examples. Because now we can work out this new kind of problem, I think, based on the fact that we've worked so many synthetic division problems. So the process is the same. You bring down this 1, and you multiply this 1 times the complex number 1 minus I, times the 0 of 1 minus I. And what is 1 times 1 minus I? 1 minus I. Now you're going to line up the real part, so you have a -2 up here, you're going to line up the real part of that product, 1 times 1 minus I, the 1 right here, with the -2 above it. And there is no, I mean, you can think of this as -2 plus 0i if it helps, but it gets messy if you write that. And then, so then you have the minus I off to the right. And then what do you do with that number? Always in synthetic division, what do you do with these two numbers? These two numbers, you always add. So you get, you add the real, so how do you add complex numbers? Well, you add the real parts and the imaginary parts. So -2 plus 1 is? -1, 0i plus -1i is -1i. And then here's where you leave room for scratch work. Because now think about what you do. You take the 1 minus I times this result right here, -1 minus I. But you don't want to, that takes a little bit of thought, so let's do it over here as scratch work. Actually, let me erase the extra stuff. Okay, so let's do it over here. 1 minus I times -1 minus I. And you think kind of like the FOIL method, right? It is the FOIL method. It's distribution. That's what the FOIL method is. So multiply the first guys together, and what do you get? 1 times -1? -1. Multiply the outer guys together, and what do you get? 1 distributed over a minus I is minus I. The inner guys? Plus I. And the last guys. So plus I squared? Yeah. And then what happens then with these guys in the middle? They cancel out, and you end up with -1 plus I squared, but what's I squared? So you end up with -1 plus a -1? Or Negative 2. So where does that go? Up. Right there. It's the same process. It goes in the same place where the multiplication would always go. Does everybody see that? Okay, negative 1 plus a negative 2 is negative 3. When you start the process all over again, 1 minus I times negative 3. So you distribute, right? Distribute negative 3 to the 1 minus I. What do you get? Negative 3 times 1 is... what you're distributing, so you're distributing to the entire quantity, 1 minus I. So you would distribute the negative 3 to the 1 and get negative 3. Distribute the negative 3 over the minus I and get plus 3I. Fit it and try and fit it in there somewhere. And then add. So what do you get when you add 6 plus negative 3 plus I? 3 plus 3I. Yay. And you get to do this process all over again. Now, what do you expect to get right here when you do the multiplication?
6.
You better get 6, and you will, because if you factor out this 3, you're going to see that you're multiplying conjugates. So let's go ahead and do it, though. 1 minus I times 3 plus 3I.
Could you factor out the 3I from the second, or the 3 from the second little set? Factor
Yes.
it out, and then it would look exactly the way the other
Yes.
did when you were multiplying them?
You definitely could.
Okay.
Yep. So if you multiply the first together, what do you get?
3
3, the outer.
minus 3I.
Well, the outer would be plus 3I.
Oh, plus 3I.
And then the inner would be the minus 3I as expected. And the last would be
Minus 3I squared.
minus 3I squared. And then you'd have, well, these guys knock each other out. So 3 minus 3I squared would be the same as 3 plus 3 as expected, or 6. And so you can use what you expect to catch mistakes. You know the remainder is going to be 0. You're told that. And I'm not going to lie to you. I wouldn't do that unless I asked you to check. Okay. So yeah, that's ugly. I admit it. That's ugly. But it gets easier from there on out. Now, 1 minus I was given to be a 0. We automatically know what's the other 0, or what's another 0.
1 plus I.
So now let's continue on with the division on the quotient with the conjugate of the last 0, 1 plus I. And this one will be easier because all the i's are going to go away in this step. Okay, so bring down the 1 and then multiply 1 times 1 plus I. What do you get? 1 plus I, and then look how nice this is. 0. Negative 1 plus 1 is 0. Negative I plus I, 0. Times 1 plus I, yeah, it's still 0. Negative 3 plus 0 is negative 3. And then distribute the negative 3 to the 1 plus I. Minus 3, negative 3 minus 3i. And of course you get 0 there. Now we started out with a degree 4 polynomial. So these are coefficients. 1, 0, negative 3 are coefficients of what degree polynomial? 2. In fact, what is that quotient?
X squared minus 3.
Ooh, we know how to solve. We don't even need the quadratic formula. Set it equal to 0 to find the remaining zeros. And what will the remaining zeros be? Yeah. So x squared equals 3. If we add 3 to both sides, take the square root, you get plus or minus root 3, which is real. So that would show up on your calculator, but the square root of 3 is not rational. So notice I didn't use the rational zero theorem here. It wouldn't have helped us because there are no rational zeros. So what are the zeros, by the way? The zeros... Yeah, I'll go ahead and list them both, even though I was given one of them. 1 plus or minus I and plus or minus root 3.